Okay, recording has started. Okay, so good morning, everybody, and welcome back to Math 115. So, a couple of announcements before we start. Let me get the screen up here. My screen doesn't seem to be working here. Oh, there it is. Is my screen having a lag here? Oh no, that looks better now. Okay, so let's see here. Let's have our announcements. Add a page in here. Okay, so first of all, the exam grades are posted. Please check your submission. So if you turned in your exam properly, I graded your exam and I wrote feedback. Exams were graded out of 58 points. So you'll see me write on your exam like 8 out of 10, 10 out of 10, whatever. That's for pretty much each problem, except for the last problem was only worth 8 points. Now those 58 points are just for the purpose of grading the exam. So all I'm gonna do is take the number of points which you got right, divide it by the number of possible points, which is 58. And that is going to be your score percentage-wise for the exam. So say if you got, I don't know, how is this gonna divide nicely? Okay, if you got 50 out of 58 points, then you will receive 50 out of 58 times 16% at the end of the semester. Okay, so this 16% is the weight of exam 1 on your final grade, okay? So exam 2 might be graded out of like 70 points, or exam 3 might be graded out of like 99 points, something like that, but they're all worth 16% of your grade. So I'm just gonna take your percentage score on those exams and apply that to the weight of the exam and add up your grade like that, okay? So if you have more questions about how weighted grades work, maybe stay after class and we can talk during office hours about it. So please check your submission. There were a couple of students who had a submission. I think I sent an email to everybody who submitted something that either an exam which was missing a page or I didn't get your exam. So please check, and if you have like a score for your exam which you really didn't expect to get, like a 0, then please reach out to me and we'll get things sorted out. I've also uploaded your homework scores. Please make sure they match Pearson. There are also a couple of students who I think have been dropped from the Pearson registration because they were working on like a trial subscription. You need to purchase the real subscription so that I can put in your grades, because I think it's not showing me what you got on those homeworks now because your subscription, your trial subscription is over now. So please make sure that you're properly like set up for Pearson. Make sure that the homework scores in Pearson also match what you see on Blackboard. And Also, make sure that looking at your exam, add up your points, divide by 58, and make sure that that is the percentage that I put in. I'm pretty sure I got everything completely right, but there's always a possibility that I made a arithmetic error somewhere in there, okay? So please just double check that stuff and make sure that everything looks good so that we can get it sorted out early. Okay, any questions about the exam? I guess I'll tell you what the average was. The average was like 79%, which was about what I was expecting. So I'd say it went pretty well. I was happy with a lot of the results. I tried to write feedback where I could. And yeah, I guess that's all I really have to say about that. Okay, so let's start today then if there's no other outstanding issues. So last time, remember, we talked about, what did we talk about? We talked all about polynomials. Okay, so, and we got through a lot yesterday. Okay, but we talked about the general form of polynomials, we talked about their anatomy, we talked about some properties of their graph, namely that they're nice and smooth and continuous. We talked about how to establish the end behavior based on the sign of the leading term and the even or oddness of the highest degree power of x. Okay, and then we also learned about the zeros of functions. Okay, so we talked about what it means for the function to have a zero at a point C. It just means that f of c is equal to 0. And we also talked about the intermediate value theorem, which remember was just to say if I start low and I end high and I have a continuous thing, then I must have hit every height which is in between those points. That was the intermediate value theorem. And then we also learned about how to graph polynomials when they're completely factored. Okay, so we talked about how to check if we're going to have, quote, passing behavior or bouncing behavior of our polynomial near a 0. And then the very last thing we did was we took a look at a fully factored polynomial, and we checked the multiplicity of each 0 to try to graph what this thing looked like. So we checked the end behavior, that told us what the ends should look like, and then we filled in the middle by checking whether each 0 had passing behavior or bouncing behavior. So that's what we did last time. Okay, and today what we're going to do is talk about how to divide polynomials. And we're going to talk also, if we have time, we're going to talk about rational functions. Okay, so I will say that dividing polynomials is one of those things in the pre-calculus curriculum that seems to give a lot of students trouble. Okay, so I'm going to do my very best to explain it as simply as I can and as completely as I can. But just know that if you struggle with this, you're not alone. And I would really recommend that you come to office hours and talk over some extra examples with me after class if this is something that you find really confusing. Okay, so don't worry. Lots of students struggle with this. It's just kind of a difficult concept. Okay, so let's start with the basics and establish the following. Okay, so we have this definition here. And what does it say? It says that a polynomial d of x, okay, is a factor of a polynomial f of x if we can write the following. We can write f of x as being equal to d of x times q of x, where d of x and q of x are both polynomials. Okay. Then d of x is a factor of f of x. So, for example, the old intuition for this, right, is if we can write 6, we can write 6 as the product of 2 times 3. Therefore, 2 is a factor of 6. Okay, that's kind of what we're saying here. Except now we're going to talk about how to do this with polynomials. For example, we could write x squared minus 2x. Why don't I make that x squared minus 3x minus, no, plus 2. We can write that as being equal to x minus 2 times x minus 1 if we were to factor it. And these are both polynomials, therefore x minus 2 is a factor of x squared minus 3x plus 2. Okay, so if we can basically factor this term out, okay, we can factor a term out, we call it a factor. And it makes sense for quadratics because we talk about factoring quadratics all the time, but we can also do this with higher order polynomials. Okay, but the important thing here is that q of x should again be a polynomial. Okay, so if we take out d of x and what we have left over is not a polynomial, maybe it's like a rational expression, then we're in trouble and we don't say that d of x is a factor. Okay. So that's about that. And this down at the bottom is just saying, why do we use these letters d and q? Well, we call d the divisor and we call q the quotient, right? Because if we were to rearrange this equation here, we could divide both sides by d and we would get f of x divided by d of x is equal to q of x, right? And if we divide two things, the result is called a quotient. And here the numerator here is going to be the dividend, and the d down in the denominator is going to be the divisor. Okay? The divisor is the thing which does the dividing. Okay, so that's the setup. Okay, so sometimes we want to divide a function f of x by a function d of x, which is not a factor of f of x, okay? So this is just to say if d of x is not a factor, okay? Oh, I'm having some feedback. Oh, seems like we're okay. If d of x is not a factor, then what is that saying? That's saying that this equation is not true. In other words, we cannot write f of x equals d of x times q of x, where q of x is again a polynomial. Well, if we can't do that, we can do the next best thing, which is to write f of x as being equal to d of x times some polynomial plus a remainder. Okay, so if d of x doesn't divide f of x evenly, we write f of x equals d of x times q of x plus r of x, right? And this is the same thing as what we did with, like, you know, regular numbers way back in the day. We might have tried to take like 8 divided by 6. Well, that's going to be 6 goes into 8 at most one time, so I would write 6 times 1 plus my remainder, which is 2, right? Oops, get that out of here. Oh no. Plus 2, okay. Right, where this 2 here would be the remainder. So this is the connection back to the intuition that you might have had from grade school. Okay, and f and d and q are going to be polynomials as usual, but r of x, okay, the remainder is, in general, it's not going to be a polynomial. Okay, it's going to be probably a rational expression. Okay, so that's what this division stuff looks like when d of x is not a factor of f of x. Okay, so how do we actually do it? This is going to be sort of a long process, but I'm going to try to explain this as best as I possibly can. There's going to be 5 steps, okay? And we're going to just go through them one by one, and then I'll go back and recover them and recap what we did. Okay, so here we have an expression, 2x squared plus 5x to the 5th plus 7 plus 4x cubed, and we want to divide it by x squared plus 1 minus x. Okay, that's what we want to do. So I'm going to teach you guys how to use long division. There's another way of doing this called synthetic division, which you can use if you want in the book. I'm not going to describe it today because it's time consuming and it's really just the same exact thing as long division, but a different way of writing it. So I'm just going to teach this way. If you want to use synthetic division, you can. Okay, so the first step is to take each of our polynomials, simplify them, and also identify which one is the dividend and which one is the divisor. Okay, so remember the dividend was f of x, and the divisor was d of x. Okay. So what do we think here for the dividend? Which expression is going to represent the dividend in this case? Let's say top or bottom. Yeah, I think we should use the top, right? And here's how you can tell which one is the divisor. The divisor will always have well, okay, I shouldn't say always. The divisor will usually have a higher power of x. Okay, here we've got x to the 5th. We're not going to be able to divide x squared plus 1 minus x by x to the 5th. Okay, because x to the 5th is a larger power of x, so it's not going to divide evenly for sure. But we can try to divide by the top one by the bottom. Okay, so our dividend here is going to be the thing which is getting divided, and then the divisor is going to be the thing which is doing the dividing. And I'm going to write them in what I call standard notation. What I mean by that is decreasing powers of x. So x to the 5th plus 4x cubed plus 2x squared plus 7. And I'm going to write the divisor in the same way. We're going to get x squared minus x plus 1. Okay, so that's step 1, identify dividend and divisor. So step 2, I'm going to insert terms with 0 coefficients and set up division. Okay, so what I mean by that is kind of hanging out in between x to the 5th here and plus 4x cubed. There's sort of a hanging plus 0x to the 4th. Okay, and I'm going to include that even though it's not really saying anything. I'm going to include it just so that when we do our long division, you're going to see why we want to have that hanging there. Okay. And I'm going to set up the division. Okay, so I'm going to write one of these division signs. And remember what the division sign should look like is we should have the dividend on the inside, and we should have the divisor on the outside. Okay, and then what we're going to get up here is going to be the quotient. Okay, so that's how this notation works. I'm just going to write it down in there. So I'm going to take x to the 5th. I've got a hanging 0x to the 4th, so I'm going to write plus 0x to the 4th. And then I'm going to write plus 4x cubed plus 2x squared. And now I've got a sort of a hanging plus 0x plus 7. Okay? So I want to write down each and every power of x. So 5, 4, 3, 2, 1, and 0. I want to write down all those powers of x. And if I have to write them down with a 0 coefficient, then I'm still going to do that. And then on the outside here, we have x squared minus x plus 1. Okay, so step 2 is done. So let me copy that down. And now we'll move on to step 3. So step 3 is to find the first term in the quotient. Okay, so my goal here is to write something up here in this green spot. All right, that's my goal. And the first thing that I should write, okay, should be the first term in the dividend divided by the first term in the divisor. Okay, so I'm going to take x to the 5th divided by x squared. And that's going to give me x to the power 3. Okay? So you can think of this in a couple ways. You can say we're taking the first term of the dividend and we're dividing it by the first term in the divisor. Or you can think of saying, what is the thing that I need to multiply x squared by in order to get x to the 5th? That's the other way of frame of reference, I guess. Okay, so I'm going to put x cubed up in the quotient. And now here's what we're going to do. This is step 4 now. We are going to take our divisor and we're going to multiply it by the first term in the quotient. Now the first term in the quotient is the thing which we just figured out is x cubed. Okay? We found the first term in the quotient and now we're going to multiply our divisor times it and we're going to subtract underneath the division sign. Okay? And I put this orange notation here which says, remember, we need to distribute that subtraction. Okay, so here's how this is going to work. Let me copy this down. Okay, here's how this is going to work. I'm going to take each and every term of this divisor here, and I'm going to subtract, and I'm going to use parentheses when I do this. Okay, I'm using parentheses here, and I'm going to take every term of this divisor and multiply it by x cubed. And when I multiply x squared times x cubed, I get x to the power 5. When I multiply negative x times x cubed, I get minus x to the power 4. When I multiply 1 times x cubed, I just get plus 1. Okay? But this, remember here, this distribute that subtraction. I'm talking about this subtraction right here. We need to subtract each of these terms. Okay, if I subtract a polynomial like that, I got to distribute that minus sign. Okay, so let's just go through what we're doing here. I'm taking x to the 5th, and I'm subtracting x to the 5th. So those guys just cancel out, and I get 0. Okay, then on the next term, I start with 0x to the 4th, and I subtract negative x to the 4th. So really, I've added, since I subtracted a negative, I will actually get x to the 4th. And this should have been a 1x cubed. Sorry. So when I subtract 1x cubed from 4x cubed, I get 3x cubed. And then all the rest of the stuff, I didn't subtract anything of like terms, so I just keep it. Okay, so now what do I have? Sometimes we call this the remainder. I don't like that terminology because it gets it confused with the final remainder, but this is technically the remainder of dividing out x cubed times whatever times our divisor. Okay. And here's what we're going to do. We're going to now repeat this process. Okay. We're going to repeat the exact same process on this new polynomial. Okay, so the next term in the quotient is going to be the term which I get by taking the first term of our new remainder and dividing it by the first term of our divisor again. Okay. So let me clean this up a little bit. My next step, I've got x squared minus x plus 1. I already divided out an x cubed. I had x to the 5th plus 0 x to the 4th plus 4x cubed plus 2x squared plus 0x plus 7. And what I did was I subtracted x to the 5th minus x to the 4th plus x cubed. And the end result was x to the 4th plus 3x cubed plus 2x squared plus 0x plus 7. Okay, and now I'm going to treat this inside thing, this x to the 4th, as our new polynomial, which we're dividing by this thing, and I'm going to reapply the same exact steps. Okay, so the next term in my quotient is going to be whatever I have to multiply x squared by in order to get x to the 4th. Well, that's x squared. Okay, and now what I'm going to do is the same thing. I'm going to subtract. I'm going to multiply each term by x squared, and I'm going to get x to the 4th minus x squared, no, minus x cubed, plus x squared. And then I'm going to get, well, these x to the 4th is going to cancel. That's really by design. That's how we chose x squared, was so that that would cancel. And then what am I left with? 3x cubed minus x cubed, that's 2x cubed. Oh boy, have I made a mistake? Why isn't it plus x cubed? Let's see here. Savannah, are you talking about this one right here? Okay, cool. Caught my mistake before I realized. Awesome. Oh yeah, talking about the one thing, yes. Okay, cool. Thank you for keeping me honest, as always, Savannah. The likelihood of me making it through a long division without making an arithmetic error is probability very close to 0. Okay, so we subtract x cubed. I made another mistake here. So this, I forgot to distribute this minus sign. Remember, if we subtract negative x cubed from 3x cubed, we are gonna get 4x cubed. Okay, and then we subtract from 2x squared, we subtract x squared, and we just get x squared. And then we've got our plus 0x plus 7. Okay, so now we just want to continue this again. Only now what I want to do is I want to find out what should I multiply x squared by in order to get 4x cubed. Well, that would be 4x. And now I'm going to subtract this thing, except I'm going to multiply by 4x. So I'll get 4x cubed minus 4x squared plus 4x. And if I subtract that, I will get, these ones will cancel, and then I'll have x squared minus negative 4x squared is 5x squared plus, no, minus 4x plus 7. I need to add a page here. Aha, you got it. Yep. You're right, Savannah. I'm lucky to have you in the class correcting all my mistakes, because otherwise I'm going to carry them all the way through and it's going to be a disaster. All right, so next up, this will be our last step, okay, because we've gotten all the way down to the x squared term, and that is the leading term in our polynomial there. So now what do I want to do? I want to take, we're running out of colors here. I want to take whatever I should multiply x squared by in order to get 5x squared, and that'll be 5. Okay, so finally I get 5x squared. I should subtract this. 5x squared minus 5x plus 5 is what I should subtract here. And the 5x squareds are going to cancel, and then I'll subtract negative 5x from negative 4x, and that will give me positive x. And then I'll subtract 5 from 7, and I will get a plus 2. Okay? And what this step said was basically repeat steps 1 through 4 to get the rest of the terms in the quotient. And then if the remainder has a smaller degree than the divisor, we are done. Okay? So since my remainder here is x plus 2, and this has degree 1, which is less than degree 2, which is what our divisor is, I'm done. Okay? And now here's what I'm going to call this. This top part up here this is my q of x. And then this bottom part here, x plus 2, is r of x times d of x. So all told, x to the 5th, what do we start with? X to the 5th plus 4x cubed plus 2x squared plus 7 divided by x squared minus x plus 1. This should be equal to q of x plus r of x. And I know that since r of x times d of x is equal to x plus 2, then r of x is going to be equal to x plus 2 divided by our divisor, x squared minus x plus 1. So this is going to be equal to our quotient, which was x cubed plus x squared plus 4x plus 5. plus 5. And then I'm going to add to this our remainder term, which is going to be that x plus 2 divided by x squared minus x plus 1. Okay? I write it like this because this was the last thing that I couldn't divide x squared minus x plus 1 out of x plus 2. So it's kind of the last thing there that I just couldn't actually divide it out. So I just keep it as a rational expression. But this is a much more simple rational expression than we started with, because our original rational expression was x to the 5th plus 4x cubed plus 2x squared plus 7 divided by x squared minus x plus 1. So I got all of these nice terms out. And then there was really nothing else that I could do, but I still had some terms left over. So I just throw them out back still with the division sign. Okay. And that is how we do long division. So let me recap really fast and then ask for questions. So step 1 was identify the dividend and the divisor and simplify them so that they're in descending order of powers of x. Okay, the next step was to insert terms with 0 coefficients and set up the division using our division sign here, this yellow thing. Okay, so I added in all of these terms here with 0x to the 4th and 0x. And then the next term was to start this process of just taking the first term of whatever we have inside and dividing it by the first term of whatever we have outside, and that gave us the quotient, the first term in the quotient. And then since we had already divided out that piece of the quotient, what we do is we take this x cubed and we multiply it by x squared, and then we subtract their product here. Okay, that was the business of the next step, so I'll erase it here. So step 4 was to multiply the divisor times the first term in the quotient, which we just found, and subtract under the division sign. We chose the first term in the quotient such that these first terms are always going to cancel. Okay, that's how we choose the first term in the quotient, is so that those will cancel. So they will always cancel. And then we'll be left with a polynomial of degree 1 less, or possibly less even than 1 less. It could be like 3 less if the terms work out really nicely. But we'll wind up with a polynomial of lower degree. And then we will just continue the process. Okay, we'll repeat steps 1 through 4 on that new polynomial. So we'll choose the next term of the quotient, being this x squared here in red, such that when I multiply it times this x squared, I'm gonna get this minus x to the 4th, and it's gonna cancel out from the x to the 4th, which we had left over. And then I'm going to be left with a polynomial of even lower degree. Okay, and I just continue this process for as long as my remainder has degree larger than or equal to the degree of the divisor. Okay, so I repeated that process. I just kept going and going and going until I wound up with x plus 2, and I said, aha, this is a polynomial of degree 1, and that's less than the degree of my divisor. So I'm going to stop now because I can't take this any further. Okay, and so then I wrote my final answer as q of x plus r of x, but I need to remember that that expression which I get all the way at the end, okay, is not r of x, but rather r of x times d of x. So when I write it down at the bottom, when I write r of x, I need to take that x plus 2 and divide by d of x in order to get r of x. So that's why r of x looks like this rational expression. and then we're done. Okay. So that is the entire process of long division. Does anybody have any questions about how we did that? Yes, it is a very long process. It takes a really long time. But you know, once you get the hang of it, it's really just kind of busy work. There's nothing particularly, there's no individual step that's very difficult. It's just repetitive because you have to keep doing this over and over and over again until until you get something which is a remainder of lower degree. Okay, so that's how we do long division. If you want to see another example of long division, I'm going to have to do it during office hours today. Yeah, going to take longer to comprehend dividing polynomials. Yep, that makes complete sense. The best thing that you can do for yourself is practice. So if you might want to stay after for office hours and we can do more long division practice. Okay, but for now I'm going to move on unless there's any lingering questions about any of these steps or about the process as a whole. Okay. I'll leave that one for office hours. Okay, so we can use long division to factor higher order polynomials in the following way. Okay, so if you saw a question on the exam that said factor this expression, x to the fourth plus 5x cubed plus 5x squared minus 5x minus 6, you would be like, I don't know how to factor that. I know how to factor quadratics. You might even know the rule for factoring a difference of like perfect cubes or something like that, or how to factor a cubic. But long division is going to help us know how to factor polynomials of any degree as long as we can do one thing. And the one thing that we have to be able to do is to guess a factor x minus a of a polynomial. Okay, if we can guess a factor and we know that it's a factor, then we know that we could write f of x as being equal to that factor x minus a times q of x, where q of x is again a polynomial, and this will have degree 1 less. And then we'll just have a cubic. And if we can guess another factor, then we could get it down to a quadratic, and then we could just apply our usual factoring scheme. Okay? So the way that we have to do this is by remembering f of c equals 0 implies x minus c is a factor. So we try to find values c such that f of c is equal to 0. Then divide f of x divided by x minus c to get a polynomial of degree 1 less. Okay, so here's what I'm going to do. I'm going to try to guess numbers which I can plug into this thing and get 0. The first one I always usually try is 0. Well, if I plug in 0, I'm going to get -6, and that's not 0, so I'm in trouble. But if I were to say plug in 1, what would I get? I would get 1 plus 5 plus 5 minus 5 minus 6 is equal to 0. And that tells me that x minus 1 is a factor. Okay? So now what I'm going to do is I'm going to do long division. I'm going to divide out x minus 1. And I'm going to do this kind of quickly here because this is not really so much about doing long division as it is about factoring. So what do we get? This is going to be an x cubed. We'll get minus x to the 4th minus x cubed. So we wind up with these ones cancel and we add x cubed, so we get 6x cubed plus 5x squared minus 5x minus 6. Okay, next step, I multiply by 6x squared. I get minus 6x cubed minus 6x squared. This becomes an 11x squared minus 5x minus 6. Next step, I multiply by 11x. Multiply by 11x, and I get minus 11x squared minus 11x. So I add 11x to negative 5x, and I get, this is tedious, 6x minus 6. So then my last term here is just going to be a plus 6. And I will then subtract 6x minus 6, and I get 0. And I knew from the start that I was going to get 0 because I knew that x minus 1 is a factor of my polynomial. And since I knew that it's a factor of my polynomial, I knew that it was going to divide evenly. Okay, so now what have I said? I've said that my original polynomial is equal to x minus 1 times this quotient, x cubed plus 6x squared plus 11x plus 6. Okay, this is what I've done. I've factored out an x minus 1. So now I'm going to repeat this process. By searching for a 0 of q of x. Okay, and I can just keep kind of pulling off factors from this thing until it looks like a quadratic, and then I can just factor as I would normally factor. Okay, that's the process here. Okay, so I want to look for c such that q of c is equal to 0. The next one I would probably try is -1. Looks like it's going to work for that one. We would get -1 cubed plus 6 plus 11 times -1 plus 6 is going to be equal to -12 plus 12, going to be equal to 0. Therefore, -1 is a 0. Implies that x plus 1 is a factor. And then I would do my division again, except I do x cubed plus 6x squared plus 11x plus 6, and I would divide it by x plus 1. Okay, and I'm just going to write dot, 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 continue on. Continue this process. Okay, so that's how we can use long division to factor higher order polynomials. However, it is contingent on our ability to guess the zeros of these polynomials. Okay, if you've done this a lot of the times you can see them before really trying anything out, just by looking at the coefficients and by understanding that when you cube negative numbers, you get negative numbers and this sort of thing. But if you can't do that, just try like -3, -2, -1, 0, negative or positive 1, 2, 3. And if none of those work, then, well, the problem is dumb. Okay. Well, that's all I had to say for today. I'm out of time, as usual. Running behind, but that's okay. I'll see everybody tomorrow. If you want to stay after class for office hours and see more long division examples, please do so. Otherwise, have a great day. Yep, my pleasure. Anyone for some more examples?
I actually had a question about the exit slip.
Okay, sure.
I think I was looking in the grade book, and I think I still have zeros for the week 2 exit slips.
Yeah. I'll have to go back. Yeah. Let me write that down.
Okay. I was just wondering, because I know I did them.
Yeah, I know why. It's because yeah.
I just figured it like automatically graded it on the due date.
Yeah, it's because I went in and put in zeros for people who hadn't submitted them, and I forgot that I had extended your thing, and I was just going through like 0, enter, 0, enter, 0, enter. So
Oh, I got.
I probably
I got.
just like skipped over your name.
Oh no, it's all good. I just wanted to ask.
Yeah. Okay, Morgan, what time works for a meeting for you? I could do maybe. I have a meeting at noon. I could do maybe like 1 o'clock. Would that work?
That should be fine. I have a class from 10:50 to 11:40 and then from 3:30 to 4:20.
Okay, let's try to meet at like 1 o'clock. And I don't know, it might have to be 1:15 depending on my meeting before that. But I think it should wrap up by 1 o'clock. So let's plan on 1 o'clock, and I'll send you an email if it's looking like my thing is going long.
Okay, that's fine. I will see you at 1 or 1:15.
Okay, sounds good. Okay, so for the remaining students, anything?
Hello, teacher.
Mhm.
Can you solve the equation that you given us in the exam?
Sure. Which one?
Question 5, part 2, F inverse.
Yeah, okay, I remember what you're talking about. So 5.1 was find the equation of a line. It was find the, here.
Oh, teacher, I mean 5.2.
Yes, I'm aware. 5.2 was about the equation in 5.1. Find the equation of line f of x such that it goes through 0, 5 and slope 3. And the solution of this was, of course, that f of x should be equal to 3x plus 5. 5.2 said.
I got the answer, teacher. I thought 5.1 is completely separate than 5.2. That's because I got. Yeah, I'm sorry.
That's okay. Yeah, so this was to do this. So if we want to do that, then we would just take y equals 3x plus 5. We'd replace x and y.
It will be x minus 5 over 3.
Correct.
That's okay. Because even though I submitted my exam, from that day until today, I'm trying to solve it. It doesn't make sense. The teacher give us like a question like that.
Yeah, that. Yeah, I think it wasn't supposed to be so much of like a theoretical question. It was just a computational problem. Okay, Jake, just 1 second, and then I will do another division problem. But okay, Abdurrahman, so in the future, if you're doing the exam and you're like, and you run into a problem like that where you're just like, I have no idea what to do, you can just email me, you know.
Okay.
And if it seems like the problem is just like, you know, totally confusing, if you have questions about like the directions, that you can certainly email me and I'll tell you, you know, I'll clear that up for you.
Hopefully I got a good score.
Yeah.
Is this 86?
Yeah,
Fair
you should.
enough.
Yeah, it should be on the Blackboard. So.
Thank you.
Yeah, no problem. Okay, so long division. Let's see, I had a problem here somewhere. Okay, so here's another example. But before we do the example, why don't we go back to the steps? Because you said step 3 is the one that's confusing you. Okay, so in other words, you're confused about how do we get the first term in the quotient? Is that right? Okay. So let me see if I can explain this in a new way. Yeah, there's not really a good way. Okay, here's how I can maybe explain it. Fingers crossed this doesn't make things even more confusing. If I want to do 2x to the fourth plus x cubed minus 16x squared plus 18 divided by x plus 2. What I'm really trying to do is this whole system is equivalent to the following. I'm trying to find q of x such that 2x to the fourth plus x cubed minus 16x squared plus 18 is all equal to x minus 2 times q of x. Okay? Times q of x. Now, if q of x was a polynomial, I could rewrite the right-hand side as like x minus 2 times something, where this is some polynomial, where I have like a x to the n plus, I don't know, I just write it out properly, where this would be some polynomial like a n x to the n plus dot 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 plus a1x plus a0, right? And if I were to FOIL this thing out, what I would do is I would take each term of this thing and multiply by x, right? And then I would add all those terms up, and then I would take each term and multiply by -2. This is just distributing, right? So that's what I would be doing there if I was trying to set that up. Okay, so the point about how we choose the first element of q of x is basically the following. I know that when I multiply this out, the largest power of x term is going to happen from the FOIL step of multiplying this x with the largest power of x on the other one. Okay, so if I was going to FOIL this out, I would get the following. an x to the power n plus 1 not of 5, because remember q of x should be a polynomial of degree 3, such that when I multiply it times a polynomial of degree 1, I get, all told, a polynomial of degree 4. So I'm going to get something like an x to the power n plus 1, and here n should definitely be 3. So this is actually really going to be an times x to the power 4. And here's what I'm going to do. I'm actually going to write plus, and then I'm just going to leave all the rest of the stuff inside their parentheses. So what I'll have left on the inside will just be an minus 1 x to the power n minus 1 plus dot 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 plus a1x plus a0. Okay. And the point is that when I do this multiplication of x minus 2 times, oh, not that one, sorry, a0 parentheses, when I do this multiplication of x minus 2 times an x to the n plus dot 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 dot, the very largest power of x term is going to happen from the FOIL step, which corresponds to x times an times x to the power n, and I get then an times x to the power 4, and that's going to be the only term of power 4. And then all of these terms, which correspond to this second part, they're going to have power less than or equal to 3, right? Because this an minus 1 times x to the n minus 1, that's really like x. We could just call that a2 x squared, right? And all of this multiplication on the right-hand side is going to give us at most degree 3. Okay? So what we're going to say here is that basically, if I were to FOIL this out, and I get an times x to the 4 plus all this stuff of degree 3, well, I can just match the right-hand side. An times x to the power 4 is the only term of power 4 on this side of the expression. So I know that an has to be the same coefficient as what is the only power of x to the 4 on the left-hand side. So this is telling me that an must be 2 . Therefore, the first term of q of x must be 2x cubed. Okay. I'm not sure if this is making a whole lot of sense, but this is kind of the idea of what's happening here. Okay, so we're going to rely on our principles of how we FOIL, and we're going to rely on the fact that basically we can take out this an x to the power 4. All right. And there's something missing from this equation here. We should also have minus 2an x to the power 3 there. Okay, so the process is basically, relying on the following. If I have a system like this, if I have a system like 2x to the power 4 plus 3x squared plus 7 equals blank x to the 4 plus 3x squared plus 7, we know what has to go in this blank in order for this to be true. Does that make sense? It has to be 2. Okay, so when we actually do our division here, what we want to do is, this is just a new way of writing this stuff, all of this crap, that's just a little bit less cumbersome. Okay. And so basically, I think you can try. I understand that you have an urge to sort of like have a real intuition for why we're following these steps. But the long division algorithm is probably something which you're going to want to memorize and do some practice and then get familiar with how it works. And then your intuition will just be based on the feeling of, understanding really this one step is the most crucial thing, and then subtracting and then repeating. And then we just do those steps over and over and over again. Okay, the first 2 steps are sort of non-steps, right? All you have to do is just write down the division in the correct way, and then it's just about repeating steps 3 and 4 over and over again until everything works out. Okay, so you probably just want to memorize those steps, but let's do an extra example so that you can see how it works. Okay, so we'll do this one from the ground up. And I'm definitely going to need to add a page in here. Okay, so we want to do this process. So what should we do first? We should set up our division, and we got to remember that there's a hanging 0x here in between the 16x squared and the 18x, or 18. So I'm going to write this down. We put 2x to the 4th plus x cubed minus 16x squared plus 0x plus 18, and then x plus 2 on the outside. Okay, and then what do we want to do here? We want to start with step 3 at this point, right? So step 3 says first term in Q is going to be equal to first term in F, which remember that's the inside, over first term in D, which in our case is going to be 2x to the power 4 divided by x, which is 2x to the power 3. So that tells us that we should have, I don't know, just copy this. That tells us that the first term should be 2x cubed. Okay, and here's why we want to choose our step 3 in that way. Because step 4 says, why don't I move this down a little bit? Step 4, subtract first of Q times first times D. Okay, so what we're going to do now is subtract, or we take this number here and multiply it times this polynomial. So we're going to get 2x to the power 4 plus 4x to the power 3. Okay. So the reason that we did step 3 in the way that we did was because we knew step 4 is coming. And we want to choose this number such that when we multiply it times this polynomial, the first term of it is going to be the exact same as the first term of what we are dividing, such that when we subtract them, they're going to cancel. Okay, that's why we choose 2x cubed, is such that when we multiply it by x, we get the same thing as the first term of our dividend. And we're trying to cancel that out so that we get a simpler polynomial in the end. Okay, so those two cancel, and then we just subtract 4x cubed from x cubed, and we get negative 3x cubed, and then we just let the rest of it come straight down. Negative 16x squared plus 0x plus 18. Okay. And now I'm going to repeat this step. Okay. And the process, I'm going to choose it in the same way. I want this next term of this quotient here to be a number such that when I multiply it times this thing, the first term is going to cancel out with this negative 3x cubed. That's what I want. So I want to add the number negative 3x squared, because then what's going to happen is I'm going to subtract negative 3x cubed minus 6x squared. And see, because of the way that I chose this negative 3x squared to be here, when I multiply it times my divisor, I get the very thing which I need in order to cancel out the term which is above it. Okay, hopefully this is starting to make a little more sense now. So let's keep going. If we just subtract a negative 6x squared from negative 16x squared, we would get 10x squared plus 0x plus 18. Okay, and now I want to put a plus sign, and I want my next term to be such that when I multiply it times x plus 2, the first term of it is going to cancel out with that 10x. So I'm going to put 10x here, so that when I subtract and I multiply x plus 2 times 10x, I'll get 10x squared plus 20x. And because of the way that I chose 10x as my next term in my quotient, these things are going to again cancel, and I'm going to be able to continue the process. So I'll be left with just negative 20x plus 18. And now these still have the same power degree, so I can do one more. I want to find the number such that when I multiply it times x and subtract it from negative 20x, I get 0. So it should be, well, let's try 20. I will get subtract 20x plus 18. And what does that simplify to? We then get negative 40x. Not a plus 18. That should have been a plus 18. That should have been a plus 40. 22. Okay, so something happened here. This negative 20x and this 20x didn't cancel each other out. They actually doubled. Should we have done something else instead? That's right, negative 20. It should have been a negative 20. If I do negative 20, then I'm going to subtract, only this inside stuff is, instead of being negative 20x plus 40, it'll be negative 20x minus 40. And when I subtract negative 20x from negative 20x, they cancel. And then I'm just left with whatever I would get if I did 18 minus negative 40. So that's 18 plus 40, which is 58.
Maybe there's a field back then that weren't populated.
Now 58 is a polynomial of degree 0, which is less than degree of x plus 2, which is 1.
Through the apex, because if it hit an apex error,
So that's my,
well, we won't get the apex error email, but we get a flow error email. And it will tell you oh, your apex didn't run, so we hit it.
so that's what we get. And now this whole thing up top is my q. So my answer will be 2x cubed minus 3x squared plus 10x minus 20 plus, and now in this parentheses here, I want to write my remainder. I want you to tell me, what should my remainder be? Well, if I put 58 here, then I could just combine with the 20 and I would get 2x cubed minus 3x squared plus 10x plus 38. In other words, this term just went in evenly. Is there something wrong here? Right, if I divide a polynomial by a polynomial, then I know that the division worked out perfectly. But did the division work out perfectly? No, we had this remainder term of 58 here. Okay, but remember here, this should be let me see if I can lead you to where I'm going here. This should be q of x. Then we should have a plus sign. And then this should be r of x. Okay. We established that 58 equals r of x times d of x. Therefore, r of x should be equal to what? If I want to isolate r of x in this equation here, what should I do? You're very close. I want to write down r of x by itself. I know that 58 is equal to r of x times d of x, so how can I get r of x by itself? Let's just focus on this equation here, where I have r of x being multiplied by something, and it's equal to something else, and I want to get r of x on its own. Is there something I can do to both sides that would get this d of x to go away on the right-hand side? So I would just be left with r. Yeah, we can divide by d of x, right? So r of x is just 58 over d of x. Now, do you remember what we call d of x? We can actually write down what it really is. Do you know what it is? Yeah, x plus 2. So r of x is 58 over x plus 2. So incorporating that into our final answer, Let me just draw your attention. I'm talking about this part here where we initially thought maybe we'll just put 58. We actually should put 58 over x plus 2. And that's our remainder. Okay, so here's what's happening. Basically, we divided out x plus 2 from this long polynomial as much as we possibly could, and we call that bit q of x. And then whatever we have left over, we just keep it over x plus 2. Okay, so let me explain really fast why that's true, okay? It comes from the same principles that we used to divide fractions way back in the day. When we did something like 4 divided by 3, what did we get? Well, we checked how many times can 3 go into 4? 1 time, and then the remainder would be the 1 left over, and then we just keep that over our divisor, right? 4/3 equals 1 1/3, right? Or 8/3, right? We want to check 8/3. We would see how many times does 3 go into 8? That's 2 times. And then what do we have left over? We would have 2 left over. So we write 2/3. Okay, so when we have this f of x divided by d of x, we check first how many times does f of x go in, or how many times does d of x go into f of x evenly? That's q of x. And then what do we have left over? Divided by our divisor. Same deal as before. Does that make sense? Okay, cool. So one more comment here. When we got to this last step, okay, we did all of our dividing, all of our dividing, all of our dividing, all of our dividing, then finally we wound up here at 58. Okay, we wound up here at 58. The analog to that, using our division, is like this. When you very first time you learned how to do this division and stuff like this with just numbers, okay? What you might have done first is the first thing you did before you decided that 4 divided by 3 would be 1 1/3, you might have said something like 4 divided by 3 equals 1 remainder 1, something like that, okay? And that's to say that 3 goes into 4 one time, and there would be a remaining possible 1. Okay, this remainder 1 is like our 58. Okay, so when we had 2 ways of writing this, we can write it as 1 remainder 1, or we can write it as 1 1/3, right? And 1 1/3 is just 1 plus 1/3, right? So when we write with ours, okay, our 58 is like our remainder here. So when we get our q of x, we have to take plus, we get our 58, and we got to divide it by whatever we were dividing by. So that's I don't know, maybe this is searching too far back in the depths of our memories, but this was how I did division of numbers and stuff way back in the day. So I'm just trying to like couple this new division algorithm with a division algorithm that you might already be familiar with. Okay, so yeah, you want to practice it more. Okay, that's fine. Do you want to see another example or call it for now or what? Like I'm going to be here until 11:30. So if you want to do more practice, we can. Enough for now. Okay. All right. Well, I hope that helped. Yeah. I guess that'll be it for today then, and I'll see you tomorrow.